Have you ever really thought about what goes into the medicine sitting in your cabinet? I mean, really thought about it? Today, we're pulling back the curtain on one of the most critical, yet kind of hidden steps in that whole process. It's a test that makes sure what you're getting is pure and safe, and it all comes down to a surprisingly simple idea.
It's a fair question, right? How do you know? Well, the answer isn't simple. It's actually a whole series of super rigorous tests. And one of the very first, and you could argue one of the most important, is a little something called loss on drying.
So here's our game plan. First, we'll break down what loss on drawing even is. Then we'll walk through exactly how it's done. We'll get into what it means to dry something to constant weight, which is a key concept. We'll look at a few special cases, and then wrap up with some of the high-tech gear that's involved.
All right, let's dive in. What is this test all about? And why is it such a big deal, like the first step for quality control?
Okay, so at its heart, loss on drying, or LoD for short, is a really straightforward idea. Think about a wet sponge. It's heavy, right? But if you squeeze all the water out, it gets way lighter. The LoD test is basically a super precise scientific version of that. You take a sample, you bake it under very specific controlled conditions, and you measure how much weight it loses. That lost weight is the volatile stuff, usually water. And this isn't just for fun. It's about making sure your dose is right and the product is stable, because too much moisture can mess with the active ingredient or even make the medicine go bad. And this is where the obsession with precision really kicks in. See, LoD is a broad test. It measures any volatile stuff that bakes off, water, leftover solvents, you name it. But if the official guide for a drug, that's called a monograph, says that water is the only thing that's going to evaporate, well, then they use a different, more specific test called water determination. It just goes to show you, they are always using the exact right tool for the job. Now let's get into the nitty-gritty. The official procedure is, incredibly detailed, but we can boil it all down to 5 main steps. Okay, let's walk through this. First up, you get your sample ready, just a gram or 2. Then, and this is key, you use a special weighing bottle that's already been dried out so you know its own weight isn't going to throw off the results. Step 3, you put the sample in the bottle and weigh it with insane accuracy. For step 4, you spread the sample out nice and even, pop it in a drying chamber, and take the stopper off so the moisture can escape. And finally, after it's done drying, you put the stopper back on, let it cool down in a special moisture-free box, and then weigh it one last time. That tiny difference in weight, bam, that's your loss on. Now here is the absolutely crucial part. The result isn't just a number. It's a number that's tied to super specific conditions. The temperature has to be controlled within a crazy tight window, plus or minus just 2 degrees Celsius. You can't just wing it. It has to be exact, and you have to report both the temperature and how long you dried it for. It's all about precision. So sometimes the instructions are a bit different. Instead of saying dry for 2 hours, they'll say dry to constant weight. So what does that actually mean? How do you know when you're there? Well, it's pretty much what it sounds like. You get into this loop, you dry it, you weigh it. You dry it some more, you weigh it again. And you keep doing that until the weight just stops changing. That's how you know all the volatile stuff is gone. But, in science, stops changing has a very, very precise definition. And here it is. This is the magic number. The change in weight between 2 of your measurements has to be less than 0.5 milligram for every gram of sample you started with. I mean, think about how incredibly tiny that is. That's the level of accuracy we're talking about. And this shows you exactly how it works. You do the first drying run, you weigh it. Then you put it back in the oven for 1 more hour. Cool it down, weigh it again. Then you do the math. Is the difference between those 2 weights smaller than that tiny little tolerance? If the answer is yes, you're done. If not, guess what? It goes back in the oven for another round. Of course, not everything they test is a nice, simple powder. Life's more complicated than that. So the official procedure has rules for all the tricky stuff too. So example, what if a substance melts at the test temperature? Well, you have to pre-dry it at a slightly lower temp first to get some moisture out before it turns to goo. And for capsules or tablets, you can't just test 1. Nope, you have to mix up a sample from at least 4 of them. That way you get a good average and make sure the whole batch is consistent. It's all about getting a result that's truly representative. So while a standard lab oven gets the job done most of the time, some materials need a more specialized approach. And this is where we get to bring out the really cool toys. Some tests require something called thermogravimetric analysis. It's a mouthful, I know, but it's basically a super sensitive scale that weighs the sample while it's being heated. How cool is that? Other times, you need to dry things in a vacuum, using tools like a vacuum pistol that can suck the moisture out at a lower temperature. And for some really specific tests, you need a special bottle with a teeny tiny tube in the stopper to keep the pressure incredibly low.
And I just love these little details. The official guide is so specific, it has this footnote that basically says, oh, you need one of those special bottles? You can get it from this company. Just ask for the antibiotic moisture content flask. It just makes this whole scientific procedure feel so much more grounded in the real world of lab equipment you can actually buy.
So at the end of the day, the loss on drying test is just one single piece of a giant quality control puzzle. But it's a really important one. And it kind of leaves you wondering, doesn't it? What other invisible scientific steps are being taken every single day to make sure the things we all rely on are safe and effective? It's pretty amazing when you think about it.